Well, the weather has pretty much shut down in Texas. Some parts of the U.S. are definitely getting weather, and for today it's New York, Pennsylvania, New Jersey, and New England. And there it is on the infrared imagery. Let's run the animation. And we've got the circulation of Tropical Storm Isaias. Hope I got that correct. No, last week I was pronouncing it Isaias, and I believe that's not correct. But anyway, whatever it is, the center of the circulation has moved up into New York, right about there, in that region right there, and there's the big shield of overcast. So this is going to be out of the picture by tonight, moving rapidly to the north, and in behind it, some cold air advection working into the central Atlantic area. Let's run things back to yesterday, about the same time when we did the supporter video yesterday. We had the system off the South Carolina coast, and running it forward, you can see it moving up into North Carolina. The spiral bands move quickly into the Fayetteville area. This is going to be about 11 p.m. And then we run that forward, and we see this other spiral band start developing just north of the Norfolk area. This produced tornadoes about 4 to 5 in the morning in parts of Chesapeake Bay. And the activity quickly moved to the north there to Delaware. This is going to be about 7 a.m. And that brings us to the current time. Huge precipitation shield, lots of rain, but it is moving very quickly north, so the accumulations are not going to be that high. And that brings us to the current time right there. Now, about those tornadoes, let's look at a radar image for last night. This is going to be Virginia, and off to the right, the Delmarva Peninsula. Maryland up at the top, and so this is that big spiral band we were talking about, and I put a dot for what looked like the most significant touchdown. This is what SPC had for storm reports, and the red area, those are tornado touchdowns. All the way from northeast North Carolina up to the Chesapeake Bay region. And just a quick overview. Most of these touchdowns were at nighttime, and the big one was this one near Whitestone. So 2 injuries, thankfully. Doesn't look like any deaths. So let's zoom in on that little area of supercells. So this whole line here is north of Norfolk in the Chesapeake Bay region. This is going to be about 9:33 Zulu, which is about 5:30 a.m. Eastern Time. All of these cells capable of producing rotation, and the one we're interested in is this one right here. I know it's kind of hard to see, but you can pick out the higher reflectivities right there, and then we switch over to base velocity. That's going to be one of the first things you look at, and you can see that, yeah, there's some very high velocities in that cell. We've got outbounds of about 45 knots, inbounds of about 15, and then we compensate for storm motion by going over to storm relative velocity, and we can pick out a very broad cyclonic rotation right there. So that's going to be centered about right in that spot there. Superimpose it on the reflectivity, and there's our area of rotation. So this whole thing is rotating. If we bring that forward, it's going to be about 2 minutes later. Looks like the circulation is kind of condensing a little bit, and there we can see both the diameter decreasing and the velocities intensifying. Now we've got about 37 out, 40 in, so that's almost 80 knots of broad scale rotation. I'm going to zoom in a little bit. So this is the spot that's going to be hit right in this area. Actually, this whole area is under the gun right there. So you can see how fast this comes together. We run that forward another 2 minutes. Now we've got what looks like a very tight circulation. That really came together in no time. 36 in, 38 out, 80 knots of rotation. That's right there. Where is that on the reflectivity? Right there. It's a embedded circulation. So this would be very difficult to pick out on reflectivity, and we barely even see the signs of strong reflectivity gradient and some of the other stuff we would look for. Spectrum width, that's another thing you can use. Well, doesn't look like anything useful there. Normalized rotation, I like that product a lot. It really does help things stand out. And yeah, that definitely picks out the circulation right there, getting values of about 1.48. And that stands out as the strongest bit of rotation there. So we'll zoom back in, take that forward. Now we seem to be getting some bad data in here. It's kind of hard to tell what's going on right there. Looks like there's a very strong outbounds and no scatters coming inbound, or it's been removed. But we can go up to a higher tilt from 0.4 to 0.8, and yeah, there's still very strong rotation. So we would take that into account. We look for that kind of consistency going from tilt to tilt. Normalized rotation. Yeah, very strong rotation still in that cell. So definitely still capable of producing damage. And there you go. That's a look at a tornadic supercell, and you see how incredibly rapid they produce tornadogenesis. So you really have to be on top of things. And sometimes it's better just kind of lay out warnings ahead of potent cells that are isolated like this one. And the area that was hit was right in here. I think the track may have gone somewhat like that. And just a quick look at street view so you can kind of see what the surroundings look like. Yeah, there you go. That's probably the neighborhood that got hit. And you can just imagine looking off to the southwest in the dark and maybe seeing a little bit of lightning and maybe a big dark cloud heading your way, coming on shore, and then heading off into the trees there. So dialing that back to the beginning of that storm there, and switching over to storm relative velocity, one thing that strikes me is the very cellular appearance of these cells. In fact, this is kind of painting in a series of outbounds like that, a series of inbounds in between. It's got kind of a two-dimensional velocity structure there going on, sort of, at the larger scales. And there's what it looks like on the normalized rotation. You can see right about here is that one cell is coming on shore. Things are broken up into cyclonic regions of rotation, alternating with anticyclonic. So basically it's going to boil down to where you get the strongest cells coming together that can convert over that strong shear in the lowest half kilometer or so into vertical vorticity. So in short, keep a lookout for those very strong organized cells. And we can see at the higher tilts that we've got a couple dominant cells, this one and this one right here, and that would be the next one I would probably watch for development. And there's a little bit of the media footage from Virginia last night. I didn't find any actual tornado footage. It was probably way too early and way too fast for anybody to capture, I would imagine. So 10 minutes in, we better head right to that national map. There's the northeast U.S., and you can see the remnants of Isaias heading inland up the Hudson River Valley, probably heading for Albany, Schenectady, and on up to Montreal. Should get up there very quick. Off to the west, we've got a frontal system lurking out there, and we covered this in the supporter video last night with the cool temperatures in the Great Lakes region. Nice 73 there at Chicago this afternoon, 75 at Detroit, and about 75 in Minneapolis. The visible satellite imagery, of course, showing that cold air advection we talked about earlier, and that's basically just filtering in behind the remnants of Isaias, and once it's out of the picture, we should see that frontal system either move a little further east or become stationary. There's the northwest U.S. this afternoon, a slow-moving frontal system moving through Montana, and behind it, what looks like a Pacific air mass building into Alberta and northern Idaho. Temperatures are kind of mild up in the high deserts, 80s, west of Spokane, and the satellite picture looking like what we see here. Central Rockies having some of the better convection, but it looks like moisture scarcity throughout much of the northwest. There's the weather map for the southwestern U.S. We've got a stationary front through central Texas. It looks like the tail end is kind of draped up there towards Las Vegas, New Mexico. South of that, we've got a mixture of moist tropical air, 91 to 95, San Antonio to Temple, and drier air off to the west. Dew points drop off towards 50, and it looks like our monsoon pattern has receded a little bit. And then further off to the west, we find the heat low showing up as a trough through the Las Vegas area, where it's 99. And the satellite imagery showing the monsoon definitely kind of shut down. Few storms going up around Alamogordo out towards Silver City, and maybe a little bit of moisture trying to infiltrate the Tucson area. I think a lot of this is mid to high clouds, but there could be a little bit of low cloud and low-level moisture making its way northward. In the southeastern U.S., we have a stationary front from the Appalachians to about Atlanta, and in through about Birmingham and all the way over to Waco, Texas. And you can see that the air mass is pretty mild in northern Arkansas and southern Missouri. We got 77 there at Paducah, and what's some other numbers? 78. Wow, that's pretty cool for Tulsa, and 76 there at Cincinnati. And that contrasts pretty sharply with these 90s covering much of Florida and southern Georgia. The deepest moisture, or I should say the richest moisture, I guess that would be the mid-70s dew points there on the northeast Florida coast. And also, wow, Texas has really dried out, 60s. Even 60s in Louisiana. So I guess the better moisture is going to be confined to this area right here. New Orleans and Biloxi, and maybe some of it trying to work its way onto the Texas coast right about there. And there's the satellite imagery. Sea breeze in Texas not really active. In fact, we got kind of a northerly flow kind of pushing back whatever boundary that is right there. But further east, we do have some cells going up in northern Georgia, close to that front. And it looks like the usual convection active anywhere from around Kennedy Space Center down to Orlando and all the way down to the Everglades. Do we have anything else on tap out in the Gulf or the Caribbean, the Atlantic? Doesn't look like it. 5-day outlook looks pretty quiet. So it's probably about time to start turning our attention to the GFS. And since we've had this very deep system coming through the eastern U.S., I'm going to start out looking at the precipitable water for our look around the country. Now, typically I'll use the dew point when things are dominated by the low-level flow, but the tropical storm plus the prevailing westerlies building into much of the U.S., that means I need to start taking into account the mid and upper level patterns. So let's run this forward and see what the precipitable water is doing. Well, yeah, it looks like we've got some pretty good values down there on the Texas coast, but a lot of the southeastern U.S. dried out by the northerly flow behind the tropical storm. So running that forward, yeah, we do get some moisture advection into the Dallas area and western Oklahoma. By tomorrow, it looks like the values are really built up across East Texas there. And looks like the value is starting to recover throughout Oklahoma and Kansas by Thursday evening. So I guess we've got just enough southerly flow to start bringing that moisture north. And let's see, by the weekend, bringing moisture all the way up into the western Great Lakes. So any disturbances coming in from the west should be able to interact with that. And I can probably see that coming together right there in Minnesota during the weekend. Looks like an MCS moving through that region. And then moving forward, it looks like that progressive flow continues. More moisture coming north into the Midwest. And looks like another MCS there in the Dakotas around midweek. And I'm kind of taking a peek down to the south, looking in the Gulf for any sign of tropical activity. And I don't think I really see any. Looks like maybe a little tropical disturbance wandering around maybe this area around the 18th. Okay, that's good enough. Let's look at the subtropical ridge. That's the other puzzle piece that controls the weather. As we can see, the subtropical ridge is really backed off, located well off the Atlantic coast and a ridge around the Tucson area. And everything in the U.S. pretty much controlled by this strong westerly flow. It's a lot like late September. So let's see what's going to happen over the next week or so. Looks like ridging on the Great Plains and troughing out in the eastern U.S. And yeah, there's that little tropical disturbance feature. Where did that come from? Yeah, that's like a little low that got sheared off down there. So that's going to hang around the New Orleans area around the weekend. So it looks like around the weekend, subtropical ridge building into Texas, but the wild card is going to be this disturbance in Louisiana around the weekend. It's not moving very much, but it's starting to create kind of a pressure gradient there in Texas. That may, anytime we get winds of around 20 to 30 knots in the upper levels in Texas, that can help prolong any storms that get going. And that'll tend to bring up the rain chances a little bit. So this is just barely borderline right there. By Monday, that tropical system still sitting in Louisiana. I would call that a little tropical disturbance. And looks like maybe it starts opening up around midweek. And this is 230 hours out, so I would say this is probably a little bit ambiguous. I do see one center around there, and it looks like another one starting to develop in South Texas. Where'd that come from? So, yeah, I do see rain chances starting to go up in Texas a little bit. Okay, that's about all I've got for this evening. Thank you for joining. And those of you supporting the Forecast Lab program, I really appreciate your contributions. Hopefully we can keep this thing going for a while. Okay. Take care, y'all. We'll see you tomorrow. Bye-bye.